Hey guys, my name is James, and in this video I'm going to show you how to install the Microswiss direct drive extruder for the Ender 3. Now this works with the CR10, CR10S5, CR10S4, CR10S, CR10 Mini, CR20, CR20 Pro, Ender 2, Ender 3, and Ender 3 Pro. And this is actually a complete kit that comes with the all-metal hot end as well as the mount for the direct drive. There is also another kit that is a little smaller that only has the mount for the direct drive system. Now between the two, I recommend the full kit because the all-metal hot end will allow you to print at much higher temperatures. While you really don't need the all-metal hot end when replacing the direct drive system, this is something you might want to consider because you will have to take out the components of the hot end anyways, so you might as well do them all at the same time. And having the all-metal hot end will allow you to print at higher temperatures, which will allow you to print exotic plastics that need the higher temperatures to melt. If you do decide to switch out the stock hot end with the Microswiss hot end with the hardened nozzle, you will have to lower the Z offset. I switched mine from a -3.9 to a -4.35 Z offset. Now all of these things that I've said here, I'm going to cover more in detail throughout the video installation, but I just want to give you some of the considerations that you might want to think about before you upgrade, because this is going to be a major overhaul. Now, the installation is going to be pretty much straightforward. You can use the PDF instructions to make it work, but the print quality will actually depend on how well you're able to fine-tune your printer and troubleshoot some of the problems that you may have. Now, there are a lot of videos on how to assemble and install the direct drive extruder, but I haven't seen a comprehensive video on how to install and troubleshoot some of the problems that may arise from the installation. So before I get started on the installation, I want to take the time to point out a few things that may help you in the decision of whether you should be getting a direct drive system or just using your Bowden system. I really love this aluminum mounting bracket. It's really lightweight and it's super strong and sturdy, and it's precision pretty well. Still, you have to account for the stepper motor that will be mounted to the top, which actually is quite heavy if you really think about it relative to the size. So that's something you should be thinking about. The Bowden Tube setup is really light, so you're going to have an easier time of fine-tuning the Bowden Tube setup than the actual direct drive system with the heavier motor that's directed on top of the mount. I know a lot of videos show you the installation part of it, but you are going to have to make some changes to your firmware. You're going to have to make some changes to your cable management. You're going to have to do a lot of these different things that you don't see or you might not have considered when watching the other videos. And fine-tuning the actual printer to make a good print, that is also going to be something that you're going to have to diagnose in part yourself, but I'm going to give you some tips that may help you out. Now, if you do decide on upgrading to a direct drive system, the cable management is going to be a process. This is going to probably be more of a process than you think. Some of the instructions on the PDF I actually changed, or throughout the video you're going to see that I'm not using completely the step-by-step instructions on the PDF, mainly because of the cable management. Some of the parts for the cable management I designed and printed it out. The Stl files are going to be in the description below. You can use those files if you need to. Let me just show you a couple of things. I'm going to cover a lot of these more in detail during the installation, but I'm just going to show you that. Let me turn on my Ender 3 and go zoom in. I lengthened the housing for the Bltouch, so the probe for the Bltouch is protected while the probe is retracted inside the Bltouch. This is really just a simple knob a small knob that I created that allows me to feed the filament inside the extruder without having any issues with the wire loom. One of the things you're going to notice is that I placed the spool on the right side. There is a reason why I put it on the right side as opposed to the left, which you're going to see. This is going to take some time. I'm just going to raise it all the way. So this is the full range of the Ender 3, and you can see that there's clearance here. If you were to have the wire loom go behind the printer itself, it will get caught on this aluminum frame, and that would, you know, be pretty bad. So you do lose about maybe 30 millimeters, maybe 25 millimeters, I would say. But having the wire loom come to the front, you don't lose any of that height. And you can see that it does move all the way to the side. Although there is a little bit of catch, not really a catch, there's enough height or clearance for it to go in and out. But you can see that there is no problem because the wires come to the front. Also, you can see that I placed a guide right here that prevents it from hitting the actual rod. There's a rod right here, the main rod, that I don't want it to get clipped. So this isn't like a guard right here. And if you look, I zip tied it to where the wires actually bend. Hold on. See, if you hear that squeaking, that's because the rod is not actually aligned well to the actual aluminum frame, and this is because I've been moving around my printer too much, and then I know that most likely the stepper motor, the mount on the Z-axis is probably a little loose. That is why you're hearing that little bit of like sort of like the grinding type of noise, and I'm gonna adjust that because I move it around so much for this video. That is why it's probably been knocked out of alignment a little bit. I have the actual wire loom go up to the top and go bend in the middle. This way there is no possible of a kink or anything like that. It gives you a full extension right here, and you're not going to have any issues with any of the wires being clipped by any of the gears. The installation process, if you look at the PDF, is pretty easy, pretty simple to follow, but you need to do the correct cable management, correct settings, fine tuning in order for the prints to come out pretty good, you know. And again, you can see that it's held right here by zip tie with the mount that I created, and then it just bends right here, which allows it to not have any major issues when moving across. So let's get started with the installation process. Now I'm using my thumb to put some pressure on the nut so that when I spin the screw, it'll come out instead of having the nut spin in place. It would be helpful if you actually have a tweezer or something to hold the nut in place rather than your finger. Next, you want to remove these two M3 screws that are holding the fan housing in place. You want to cut all the zip ties to at least the midpoint of the wire loom. This is going to allow you to unsheath the protective wire mesh on the wire loom. Put a temporary zip tie on the mesh after unsheathing it. This way you can actually separate the wires from the thermistor and the fan. This is going to make your job a lot simpler. Also have your gantry low enough to where you can actually put the fan on your bed. Now in many videos I have seen people let the fan hang freely off the wires. If you do this, there is a possibility that the wires may break. So if you don't want to take any chances, place the fan on the bed, removing any stress on the wire. So guys, before you go any further and start disassembling everything, I want you to take a couple of considerations. On this video, I'm going to be replacing my hot end with all metal hot end. So I am going to be removing some parts. But if you do plan on keeping your stock hot end, all you have to do is remove these two screws right here. This one right here and this one right here. All you have to do is remove those two screws. Now for my situation, I really don't need the extra nozzle and Bowden tube because I have extra spares. But if you want spare parts, you want to remove the nozzle and the Bowden tube while the hot end is hot, because once you remove the thermistor and the heating element, like right here, if there's still filaments stuck inside the nozzle and between the Bowden tube, you're going to have a very difficult time taking out the nozzle and the Bowden tube on the other end. The only way to remove it is to stick another heating element inside with the thermistor, or use like a blowtorch, lighter, whatever it is, to get this heating block hot, and then unscrew it, because again you are going to have residue filament left inside the nozzle between the threads and the Bowden tube. So just keep that in mind. This is going to be a Phillips screw head. You want to be very careful when you remove this thermistor wire. You want to first loosen this screw. In combination, you want to loosen this grub screw on the bottom, which actually holds the heating element in place. Here I'm checking to see if the heating element is actually loose. The thermistor and the heating element have to come out together. If you're not careful and one of the element is actually stuck for some reason or another, and you put a lot of force, there's a possibility you're going to split the wires. So just make sure that the screw that holds the thermistor in place is actually completely out before you decide to push the heating element with a screwdriver or Allen key. Now remove the two M3 mounting screws that hold the hot end in place. At this point you can remove the belt. There are two tabs in the back which slide across and out. Loosen the bottom wheel using a Allen key and a socket wrench. Once it's loose enough, you should be able to tilt the entire mount and get it off the rail. Remove the wire connection to the extruder motor. Remove the 4 mounting screws on top of the extruder motor, starting with the lever. And remember to cradle the motor so you don't accidentally drop it. Remove the wheels from the mount. Remember that you will be reusing many of these components, so set them aside and don't lose them. You can also wipe off any excess dust that may have developed on the wheels. Now this aluminum mount is super light. Now I did decide to use my original screws, but there are extra screws inside the box that have Loctites on. So if you don't know what Loctites are, they're the adhesives around the threads that help bind the threads together. Now the most common mistake is going to be tightening these screws to where it binds the wheels. You want to have it tight enough to where the vibration of the motor and the printer itself doesn't loosen these screws. However, you don't want to over tighten it to where it actually starts binding the free movement of the wheels. For those of you who are beginning in 3D printing, you may hear somebody say eccentric nut, eccentric nut. The 2 top wheels are fixed. This bottom wheel, compared to the 2 top wheels, has an eccentric nut. And this is an adjustment nut which allows the wheel to grip the rail tighter or looser based on the adjustment of the nut. This bottom wheel, you don't have to mount it right now. You can mount it loosely if you're prone to losing parts. Later on, you will have to remove this wheel to mount the assembly to the printer. Loosen the grub screw on the side and remove the gear from the motor. You are going to reuse this motor. These are the Loctite screws that I was referring to earlier. These have blue adhesives on the threads. The wire connector should be on top. There should be 4 places to screw in the motor, 1 on each corner. You're going to screw in the top and the bottom left with the smaller screws. The one on the bottom right you're going to leave open for the lever. Find these 2 bags, one has a lever and one has a spring. The lever goes on the right side. Again, the lever has to move around. You don't want to over tighten. Now on this motor shaft, you're going to notice there is a flat side. This is how you're going to align your gear with the grub screw. So the grub screw actually goes on the flat side of the shaft. You may have to loosen the grub screw a little bit before trying to mount your gear to the shaft. You may have to give it a little bit of a wiggle. If you notice, once I let go of the gear, it's going to fall down. So the best way to align the gears is to actually add some filament. If you're having trouble slotting the filament inside the bottom hole, it's because the gear is too low to the motor. If you take a look at the gear, there is a groove in the middle of the gear where the filament is supposed to go inside or align to that groove. So once I raise the gear, the filament actually slots in. And you can see that the gear rotates by the movement of the filament. Close the lever. Applying a little bit of pressure on the lever, rock the filament back and forth. You'll find the teeth of the gears align into place. Once it aligns into place, find your grub screw and tighten the grub screw. Recheck to see if the gears are still aligned. Find your pin, insert your compression spring, and lock the lever in place. Tighten this knob flush to the tip of the pin. Later on, if you need to, you can make some adjustments. The filament should rock back and forth freely. You want slight resistance to the filament. Again, you want to have that pin flush with the knob. This is the heating block, and it does have a bottom and up. This is the top side. Now the cylinder looking thing is the heat break. This is what separates the heating block from the heat sink. Attach the heating brake to the top side of the heating block. This is what makes a lot of the all metal hot ends special. The heat brake creates more separation between the heating block and the PTFE tube. You really don't want the PTFE tube getting really hot over 250 degrees centigrade, because if you do get it above that temperature, it will start off gassing. Especially with the older type of hot ends, the PTFE tube would sit very close to the heating block and they would often melt. Everything doesn't have to be super tight because everything will be retightened later on when the heating block gets up to temperature. Insert the grub screw. This Capricorn tube has a different type of cut on each end. One is flat where it goes toward the bottom or the heat sink. And the other end has an angle cut which goes to the extruder. Mount your hot end to the extruder. Remove your bottom wheel. Mount your assembly to the gantry. Then you're going to reattach the bottom wheel to the mount. On the front side, I added a washer and then I added the nut. So you're going to hold the nut in place with one of the wrenches that came in the box, and then you're going to use the Allen key on the back side and tighten the screw. Move your assembly from side to side. Make sure that the wheels roll smoothly across the rails. Now between the plate and the bottom wheel is your eccentric nut. You're going to adjust the eccentric nut to eliminate the wobble on your assembly. So if you find wobbling on your assembly, what you want to do is get a wrench and give this eccentric nut about 1/8 of a turn. Based on the current position of the nut, it's going to either close or open the gap between the wheel and the rail. So you want to turn it about 1/8 of a turn, and then you want to check if there's a wobble. If you still find a wobble, again, do 1/8 of a turn. So this is a continuous process where once you eliminate the wobble, you're done. So before I move on, I wanted to clarify something. What I mean by a wobble is a front to back rocking motion. I'm not talking about the side to side motion. You really don't need to put a lot of pressure. All you need is to use one finger to see if it wobbles back and forth. So it is a front to back motion, not the side to side motion. Not the motion that goes like this. It is, if the wheel is loose on the bottom, it will rock front to back. If you remember on the video, I put the washer in the front. There may be a case where you may have to put that washer in between the wheel and the eccentric nut. That's a judgment call. So that's kind of like a spacer in case like the mount has been milled or cut wrong, or there's a gap in the spacing between the wheels. So again, I didn't find that to be the issue with mine, so I placed the washer in front so I don't lose it in case I may need it later on. Just make sure your top wheels are aligned with your bottom wheels, and if not, you may have to add that spacer or washer in between the eccentric nut and wheel. You want to orientate the heating block into the correct position. You want to eliminate any gaps between the heat sink, the heat break, and the heating block. So apply some pressure in the up direction before tightening the grub screw. Now the thermistor sensor has to go inside this hole. Just be careful when you're trying to insert the thermistor. The thermistor sensor wires are very delicate. Just take your time with this portion of the install. Now lock the heating element in place by tightening the two screws below the heating block. This clip locks the Bowden tube in place. Insert it between the metal slot after seating the Bowden tube. On my setup, I decided to remove the Bowden tube altogether. If you're going to use regular PLA, I don't think it's even necessary. But if you do decide on using abrasive filaments, then it may be necessary to protect the metal parts. Even if you do decide to use the Bowden tube, I would just cut it short. Having a long Bowden tube is unnecessary and it just makes it cumbersome. So this is the extension cable for the extruder. The tabs match up and only go in a certain direction, so you can't make a mistake on these. The other end goes to the original line. Make sure you press down on the Capricorn tube to seat it properly so there's no gaps before you clip on this red tab that locks it into place. You want to power on your printer and get the nozzle up to temperature. Around 215 is alright. While the hot end was at temperature, I reseated the heat break and nozzle to the heating block using a counter torque method. Then I reseated the heat break to the cooling block, making sure that there was no gap between them. Add some filament. Extrude some filament. Check to see if there are any gaps between the nozzle, the heating block, and the heat break. If there are any issues, you will be able to see the plastic oozing out of the gaps instead of the nozzle. If everything looks okay, you can power off the printer and proceed with the rest of the installation. If there is plastic oozing out of other places than the nozzle, then you have to re-tighten wherever the issue may lie. There seems to be no issues, so power off the printer and add the silicone sock. You can close up your unit. Don't forget to add your Bltouch mount. Now I already inserted the nuts to the Bltouch mount. These nuts are M3s. Check the description below. The reason why I switched them out was because I did not want to interchange between the Phillips screw and the Allen key. You can use the original screws and nuts that come with the Bltouch. Just use a washer. If for some reason you need to take out the Bltouch from the housing, don't use like a pen or a different tool. That might break the probe. Use this tool instead. It's going to be able to push out the Bltouch to the opposite end. Mount the Bltouch with the 2 screws on top. Cut the temporary zip tie. Zip tie the bottom. Loosen these 2 screws. When the belt tensioner is loose, you can install the belt on the mount. There are 2 slots in the mount. The belt should slide into place. This is actually a mount for my transmitter for my DSLR. I'm actually going to remove this mount so you guys can see what's happening. You do not need to remove anything. All you have to do is loosen the 2 screws. Now, if you ever loosen these screws too much and the piece falls out, no worries. Wrap the belt around the roller. These are T-nuts. They actually slide inside the rail. Just align the T-nuts and the screws and tighten. Now, some people like to use something like a flathead and wedge it in between the roller and the rail and use it as a lever to tension the belt. You want to have the belt at a certain amount of tension, otherwise the belt is going to be too loose. I actually like to just pull the roller from the side. Pull the roller away from the printer and then fully tension these 2 screws. If you have a side mount, go ahead and remove it. Remove the top rail. Relocate your wires from the back to the front. Reassemble your top rail. Add your filament spool to the right. I'm just going to go over this right here. If you want to look specifically where I put the zip ties, I put the zip tie right here. This is a mount. Again, there's an arm that comes out. The wire sort of seated right here, and I put a zip tie right here. These 3 wires come together. Put a zip tie right there. Again, a zip tie right here. There's an arm that comes to the side right here. And then you can see I just placed the wires inside right here. Zip tie right here. Zip tie. So this folds like that. So here's the rear. The cables come out. It turns to the right. Just turn it to the right and then loop it out. I put in a zip tie, zip tie, zip tie. This is the larger extension for the extruder. As you can see, there is the clip right there that tied the extension together. I just wound it together and then put a zip tie right here. You just open this up. This just opens up like this. It just slides in, and then it's held by a T-nut right here. There's a T-nut inside the rail. This is for the bed. This does not go inside the guard. And you can see that I kind of like looped it around, and you definitely need this knob. This is going to help you push in and pull out the filament. As you can see, there is no PTFE tube. The filament just goes straight down the hole. If you want, you can cut a small PTFE tube and just put it inside there. But if you use a longer Bowden tube, I find it to be cumbersome. So just cut it short and you should be fine. Now that we completed the actual hardware installation to the printer, we're going to go to the software side. For this part, I'm going to link you to a couple of other videos that's going to be in the description below, so go ahead and look at that description. You need to follow these 4 steps in order for you to have a good print. It does get a little bit lengthy, so it is going to be covered in different videos. It's not going to be specifically for the direct drive setup, but everything you need to know will be covered on those videos. Number 1, you're going to have to offset your Bltouch in reference to the nozzle. Okay, this is going to be offset from 43, and the Y is going to be a 5. These are the actual values for my direct drive extruder. Compile and upload. Number 2, you're going to have to pit tune and calibrate your hot end. Number 3, you're going to have to calibrate your E steps. And number 4, you're going to have to actually make some changes to your slicer program. So whether you're using Cura or any other slicer software, what you want to do is change your retraction settings. Now on a typical Bowden setup for the Ender 3, you're going to have around like 6 millimeters. With the direct drive system, you don't really need that much of a length because the distance of the extruder to the hot end has actually been reduced. Most people say put it under 1 millimeter. As a matter of fact, like 0.5 millimeter. And some have said that remove the retraction altogether. You don't really need it once you use the direct drive system. However, I have mine set at 0.4 millimeters. So I'm just going to slice this and then print this out. So you want to go to settings, printer, select your printer, machine settings, and I'm just going to open this up. Right here where it says move the start position, you want to change that to a, instead of a 0.1, change it to a 4. Go down the line, change everything to a 4 like that. Then you're going to close it out. Close. I'm going to slice this cube and then preview. Basically, we're done. Guys, I hope you found this video helpful, and if you like this video, go ahead and smash that like button. If I forgot anything in the video, please let me know in the comments below. Go ahead and share this video. Thanks for watching. I'll see you next time. Smash that like button. Smash that like button.